In this diagram, we have two parallel lines indicated by the red arrows, and we have a line that is cutting through or intersecting through both of those parallel lines. That's known as a transversal. And that transversal we're going to call line L. Notice that I used a cursive L to name the line. And that transversal actually creates something very easy to work with, which is every acute angle on this whole diagram. So we have 8 angles that are made by that transversal. Angle A, B, C, D, angle E, F, G, and H. All the acute angles are going to be equal and or congruent, same thing. And all of the obtuse angles are also going to be congruent. And we can prove that a number of ways. So we're going to start by the word vertical. Vertical angles are angles that share the same point. For instance, look at A. A right here is sharing the same point as C, and it's opposite of C. So A and C are going to be a pair of vertical angles, and that means they're going to be congruent. So vertical angles are congruent. And another pair is going to be B and D, because B and D share that same point right here, and they're opposite each other. And then on the other side with E, F, G, and H, we have two pairs. What is E paired with? E is going to be vertical with G. And what is F paired with? F is opposite of H. So those are the 4 different pairs of vertical angles. So those are all congruent. Supplementary means they add to 180 and they make a straight line. So let's just talk a couple examples there. I'm just going to concentrate right here on E, F, G, and H. So let's talk about what is E supplementary to. E is going to supplement F, because E and F make a straight angle, and E is also going to supplement H, because E and H make a straight 180-degree angle. So E supplements F and H. Now I want you guys to look at angle F and tell me what 2 angles supplement F. F is going to make a straight angle if we combine it with E, and F would also make a straight angle if we combined it with G. So it would be E and G. Corresponding angles are in the same location. So for instance, if I was saying where angle A is, I would say that is in top left. So what would be in the top left on looking at E, F, G, and H? So what corresponds to that location? And I'm looking at angle E. So corresponding would be A and E. Angle A and angle E are going to correspond. What would correspond with angle C? I'd say angle C is the bottom right. And look over here on the right side at E, F, G, and H. Which angle corresponds with C? And I'd say G is going to be the bottom right. So we could say C and G are corresponding. And then angle D and angle H are corresponding. And angle B and angle F are corresponding. And corresponding angles are going to be congruent. So we can say corresponding angles are congruent and they're in the same location. All right, alternate interior angles means that they are on the inside. Now what 4 angles are on the inside? And I would say B and C and E and H. They're all facing inward towards each other. So alternating means that they are on opposite sides of the transversal. So for instance, here we have angle B would be above the transversal, angle H is below the transversal, and they are alternating, and they are both interior angles. So B and H would work, angle B and angle H. So that means they are going to be congruent, and angle E and angle C are that's the other group that we have there. So angle E is on top, angle C is on the bottom, so they're alternating on that transversal, and they are interior. So E and C would be our other pair. Okay, another relationship we have is alternate exterior angles. And same thing with the word alternate. The word alternate means opposite sides of the transversal. So for instance, A and D are both exterior angles because they're facing outward, and F and G are both exterior angles because they're facing outward. And to talk about alternating, look at A. A is on top of the transversal, G is on the bottom of the transversal. So we'd say angle A and angle G are going to be alternate exterior. And the good thing is we know that they are congruent. So even though they're far away, we know their relationship. And the other one we're going to look at is angle D. Angle D is on the bottom of the transversal, so alternating would be look above the transversal at the other exterior angle, and that's F. So D and F are also going to be alternate exterior, and that means they have the same measurement. They're congruent. Okay, and then our last one I want to look at is consecutive interior angles. Consecutive interior angles have a different relationship. They are going to add up to, or the sum of them is going to be 180. So they add to 180 degrees. And these angles are going to both be interior. So I'm going to look at all four interior angles, which would be angle B, C, angle E, and H. And the ones that are consecutive, they're not going to alternate. They're going to be on the same side of the transversal. So consecutive means next to each other on that transversal. So they're on the same side. And I'm looking at angle B, and the consecutive interior with that would be angle E. So they're going to add up to 180. And the other one I'm looking at is C, angle C, and angle H. They're both on the same side of the transversal, and they're interior angles. So C and H. So if you knew angle B was 80 degrees, you know angle E would have to be 100 degrees because they have to add up to 180. Now let's try an application to what we've learned. Here we're given that angle C is 2x minus 1 degrees and angle H is 3x minus 34 degrees. And we know that their relationship is consecutive interior, so that means that they add up to 180. So we're going to set 2x minus 1 plus 3x minus 34 equal to 180. And we're going to solve for x, and that will help us to find our missing angle, and we'll plug in our value for x to find both of those angles. And they should add up to 180. That's how we can check it. So combine our like terms. 2x plus 3x is 5x. Negative 1 minus 34 is negative 35. And then we have a two-step equation, so add 35 to both sides. And we're going to get 5x equal to 215. And then our last step, you may have guessed, is we're going to divide both sides by 5. And divide those by 5, and we're going to get x equals 43. Now let's plug that 43 back in, and that will help us to find what angle C and angle H equal. So if x equals 43, plug it in to 2x minus 1, and we get 2 times 43 minus 1, and 2 times 43 is 86. 86 minus 1 gives us 85 degrees, and that's what angle C is. And then the other one should be 95, but we're going to check it by plugging it back in to make sure we did it right. And as I plug that 43 in for x to the H angle, I get 3 times 43 minus 34. 3 times 43 is 129 minus 34, and that is indeed going to give us 95. So angle H is 95. double check your work. Make sure that 95 plus the 85 add up to 180, and indeed they do. Now let's try another application. Angle A is 4x minus 46 degrees, and angle G is 2x plus 10 degrees. What is their relationship? They are alternate exterior angles. And if you'll recall, alternate exterior angles are congruent. So knowing that they're congruent, we can set these two expressions equal to each other and solve for x, and then plug it back in to find our angles. So setting those equal to each other, I'm going to subtract 2x from both sides, and I get 2x minus 46 equals positive 10. Add 46 to both sides, and I'm going to be left with 2x equals 56. And then I'm going to divide both sides by 2, and x is going to be 28 degrees. Actually, it's just 28. It's not at degrees yet until we plug it back in. So if x is 28, I'm going to plug that 28 right back in for angle A. So 4 times 28 minus 46 is going to give us our degrees for angle A. 4 times 28 is 112. Minus 46 is going to give us 66 degrees for angle A. I'm going to plug in the 28 for x for angle G, and 2 times 28 plus 10. 2 times 28 is 56. 56 plus 10 is going to give us 66. So angle G equals 66 degrees. And these are both equal to each other. Does it make sense in this problem? No, we'd probably think they were obtuse angles from the looks of it, but doing the math is going to say that they're 66. So just keep in mind they're not always drawn to scale on these.